Okay, so this is off the trig unit test review. In the triangle related rates here, number one. So in the triangle shown, if theta is increasing at a constant rate of 3 radians per minute, at what rate is y decreasing in units per minute when x equals 3 units? Okay, so let's list out all the information that we have. So we know that theta is increasing at a constant rate of 3 radians per minute. That's d theta dt. Positive because it's increasing. At what rate is y decreasing? So we're looking for dy dt when x equals 3 units. Okay. Okay, so we're looking for dy dt. So typically we want to involve y, and we're always trying to take advantage of a constant, right? So anytime you see a constant, you want to involve it. We don't want to involve x because we don't have dx dt. And also we want to take advantage of that constant. So we want to choose a trig function that's going to hit what we're looking for, or something related to what we're looking for, theta and 5. So that's going to be what? Which trig function will hit the theta, the y, and the 5? Sine, cosine, or tangent? For tangent, it's going to be opposite over adjacent. Cosine, yep. Sepatoa. Yeah. Morning. So I have a review session packet then. Okay, so cosine theta equals y over 5. Okay, we want to find the derivative of this equation, but remember time is going to be our independent variable here. Cosine's derivative we can take care of, but this y over 5, I'm going to rewrite this so that I don't have to deal with quotient rule. I'm going to pull that 5 out as 1/5. Okay, so now I can find the derivative. Cosine becomes negative sine. One fifth y becomes 1/5 dy dt. Okay, so we have our derivative. Now we're just trying to find a way to solve for dy dt, and we're now going to see what information we can fill in, right? So dy dt is the unknown, so that should be what we're looking for. D theta dt we have, which is 3 radians. So the only thing missing that we need to find a replacement for so that we can solve for dy dt is we want to figure out what sine is, right? What sine of theta is. So we don't want to get caught up trying to figure out what theta is. We don't care what theta is. We want to know what the entire ratio of sine theta is. So that's going to come from our triangle. So let's fill in this triangle with some numeric details along the side lengths. So we know x is 3. We know the hypotenuse is 5. So we can use Pythagorean theorem and figure out that missing side. A squared plus b squared equals c squared. That missing side is going to be 4. So what's sine of theta going to be based off of this triangle? 3/5. So we have everything that we need to find dy dt. So negative 3/5 d theta dt, which is 3, equals 1/5 dy dt. Okay, negative 9/5 equals 1/5 dy dt. I can divide that fraction, divide this fraction over. So dividing by 1/5 is the same thing as multiplying by 5/1. So dy dt equals negative 9 because the 5's cancel out. We're not told what the specific unit is, so we can say units per minute. Morning. Morning. I got a help session packet there if you want to use that. Okay, any questions with one? Particle moves along a horizontal line so that at any time t, its position is given by x of t. Find velocity, find acceleration. So we're just going to find the first derivative, the second derivative, and power rule and cosine's derivative should help us get there. Okay. 2 and pi are just coefficients, so t is the only variable there. So 2 pi t becomes just 2 pi. Cosine becomes negative sine of u times u prime. I can clean that up and then get ready for my second derivative. Okay, acceleration. 2 pi is a constant, so that's just going to go to 0. 2 pi is just a coefficient. It's just going to hang out in front of sine's derivative. There's no need for product rule here. Pi is not a variable. I mean, we could go through product rule, but it would feel unnecessary and messy. So we'll just let that 2 pi hang out and just find the sine's derivative, which is cosine of u times u prime. These are both outside my cosine, so I can move these together and combine those. Okay, any questions? Okay, part C. What are the values between 0 and 3 for which the particle is at rest? So particle at rest. What's our strategy? If we want
T equals 0.
Good, v of t equals 0. Yeah. Particle at rest means I'm not moving. If I'm not moving, that means I have 0 velocity. So I'll set v of t equals 0. Okay, so I'm going to try to figure out a way to get that sine 2 pi t, or get that sine 2 pi t by itself. Okay, I can divide both sides by 2 pi. That's going to allow me to get that right side to be just 1. Okay, so we have this strategy of solving for t by involving inverse. So we're going to just pretend like this parentheses is its own variable and move that sign over. So anytime I want to move sign from one side of the equation to the other, I'm going to involve inverse sign. So I'm going to say 2 pi t equals inverse sine of 1. So what does that mean? Well, inverse sine of 1, this is really telling us we want to list out theta values that will allow sine to be 1. So this represents theta. So in other words, this is basically saying what theta value will allow sine theta to be 1. So let's think in terms of radian measures here. So when is sine equal to 1? And theta is
Pi over 2.
pi over 2, okay? And not 3 pi over 2, right? Because 3 pi over 2 is -1. Now what's going to happen is these values are going to shrink because we're going to have to divide by 2 pi and all these numbers are going to shrink. So what we want to do is we want to list out more coterminal angles past the 2 pi mark so that we can make sure we have all the values between 0 and 3. Okay. So the way we do that is we're going to keep adding 2 pi until we feel like we have more than enough. Okay. So plus 2 pi, same thing as plus 4 pi over 2, just to match the denominator, right? So what's the next value out? So pi over 2 is one solution. Another solution is what? 5 pi over 2. Let's keep going. Let's do a few more because these values are going to shrink and we want to make sure we don't miss out on any that's close, that we need. Okay. 9 pi over 2. Let's do 2 more here. One more. 17 pi over 2. Okay, so we're going to solve for t, divide by 2 pi. Dividing by 2 pi is the same thing as multiplying by the reciprocal, 1 over 2 pi. So let's see what t values we end up with. Okay. Multiply all the pi's in the numerator and denominator will cancel out. That's nice. So I'm left with 1/4. So let's see how these values are shrinking. Next up is 5/4. Next up is 9/4. 13/4. 17/4. Now we only want values between 0 and 3. So which values did we have is outside our interval? Have we gone too far? Yeah, so 12 over 4 is 3, so no, 13 over 4 is more than 3. So that's out, that's out. So we have 3 values between 0 and 3 where the particle is at rest. So that's important to help us do part D, because now we can create a velocity sign line and test the interval, and then we can decide, okay, which interval this particle is moving left, which interval moving right, right? So negative velocity would be moving left, positive velocity would be moving right. Right, so let's create our velocity sign line. I'm going to clean up my velocity function a bit, factor out a 2 pi. Okay, so I'm going to choose values in each subinterval here. Here I'll choose 1/8. Here I'll choose 4 over 4, which is 1. Here I'll choose 8 over 4, which is 2. And here I'll choose 3 over 2, which is 10 over 4. I'm sorry. See, 9 over 4, 10 over 4, which is 2.5. Okay, 2.5. Okay, so 1/8 in for t here. I get a sine of 2 pi over 8, which is sine of pi over 4. Now, any sine of pi over 4 is root 2 over 2. That's like less than 1, right? Everything's less than 1. So that's going to be a positive value. If I plug in 1, sine of 2 pi is 0. 1 minus 0 is 1. So all these are actually going to be positive. Sine of 4 pi is 0. 1 minus 0 is positive. Okay, 5 halves. That's going to end up being sine of 5 pi, which is 0. 1 minus 0 is 0. But the process is there. Moving left, never moving left. Moving right, we have to state these 4 intervals. We can't just say from 0 to 3 because these are all stopping points. So it's only moving right or stopping. Actually, we're going to include 0 and 3 because 0 and 3 are not stopping points. It's actually moving at 0. If I plug in 0 and 3, it's giving me a positive value. So I'll put a bracket around 0 and 3. Okay, so we did the related rates. We did a particle motion. Let's do implicit differentiation. Okay, next page. Find dy dx. We know instantly that we have to involve implicit differentiation, because anytime you see y's mixed into the equation, or y not by itself, or y attached to something else, we got to do implicit. We got to collect our dy dx's. Okay, so anything else stand out that we have to involve besides implicit? Product rule, yep. That y secant x, to recognize these as two separate terms that are being multiplied, we got to go through product rule. Okay, f prime g plus f g prime. Y's derivative is 1, but we need to attach dy dx since we're collecting dy dx here. Okay, g prime secant becomes secant tangent. Twelve is the constant. 12 goes away to 0. 3y becomes 3 dy dx. And 10x squared becomes 10x.
dy dx is the variable to something.
Not, no, we only do dy dx if we're asking for y's derivative. So you see how there are two y's here? So when this y's derivative gets activated, we need to attach dy dx. With this y's derivative, yeah.
You get y tangent y, or do you then attach a dy dx?
There we go. Yeah, it will be c. Yeah, then the dy dx won't pop up until g prime. Okay, so we have two dy dx terms. We want to put them on the left side, and all the non-dy dx terms will move right. Okay, factor out dy dx and divide the parentheses over. Okay, any questions with 3? Okay, let's do one more here. This is mean value theorem. Find the value where the average slope equal to the instantaneous rate of change. So the nice thing is we are dealing with sine. There's no asymptotes. There's no variable in the denominator. So we know our function is continuous and differentiable. Okay, just like with mean value theorem or Rolle's theorem, where our next step is always finding the location of the endpoints. Right, so no derivative yet. We're just going to insert our endpoints into the original function. Sine of negative pi. If you don't recognize negative pi, you can add 2 pi to it. Same thing as pi. Sine of pi is 0. So negative pi minus 0, which is negative pi.
Those were continuous differentiable because they were fractions.
Because it was sine or cosine. That's right. Yeah, look at the equation and see if there are asymptotes. If there are asymptotes, then you got to list those asymptotes and see if they interfere with the interval, right? So if the sine and cosine, you're safe. If it's other trig functions, then we got to worry about asymptotes because tangent, secant, cosecant, cotangent, they all have asymptotes except for sine and cosine. Okay, f of pi. Okay, so sine of pi is 0, so this ends up being pi. Okay, so not the same values, which is fine. These would have to be the same if it was Rolle's theorem, but mean value theorem, we can have different slopes. Doesn't have to be a slope 0, but we still have to take the time to find the slope between the endpoints. So we do change in y over change in x. Pi minus negative pi divided by pi minus negative pi. Two pi over 2 pi. 1. Okay, so we're done with the algebraic portion. Now we can move on and involve the calculus. So what's our next step? Derivative, right? So we set the derivative equal to the slope, and that's where we're going to find our answer. So we know that somewhere along the way, this graph must have a slope of 1. And now we're just looking for the location where this curve has a slope of 1 between these two endpoints. Okay, so x becomes 1. 2 sine x becomes 2 cosine x. So now we're just setting our derivative equal to slope of 1. Remember that 1 doesn't go in for the x, the 1 goes in for the slope variable. Okay, let's move that 2 cosine x to the left side to make it positive. I'll move the 1 over to the right. I get 2 cosine x equals 0. Divide by 2, I get cosine x equals 0. Okay, so where's cosine equal to 0? Mm-hmm. 3 pi over 2, okay. Now, our interval is between what? Negative pi and pi, so we probably need to find some coterminal angles on the negative side. So how do I find coterminal angles on the negative side? Subtract 2 pi, right? So I'm going to subtract 2 pi, which is 4 pi over 2. I'll subtract 4 pi over 2. So 1 pi over 2 minus 4 pi over 2 is negative 3 pi over 2. 3 pi over 2 minus 4 pi over 2 is negative pi over 2. I just want to list out a couple of options and see which one lands inside my interval. So which one of these values will land nicely between negative pi and pi? So here's my number line here. Imagine this is 0 here. Right, so negative pi over 2 is negative 1/2 pi, right? So that should be safely in here. Pi over 2 is also within the interval. Now 3 pi over 2 is too far outside our interval. And so is negative 3 pi over 2. So we're just looking at what's between negative pi and pi. And we see a couple of options, right? We're guaranteed at least one. We may have more than one. In this case, we do have more than one. We have 2 locations on this curve where there's a slope 0 between our endpoints. Okay, I'm just gonna continue picking out problems from this packet. This is kind of like a hodgepodge of this problem, so I just included the key in here. So tomorrow's help session, I'll just continue to pick out problems. And any additional ones that you may want to do. Okay.